Kia ora tātou. In this video we will look at the equilibrium expression. So the equilibrium expression is the equation that we use to work out the equilibrium constant. So let's go back to our old equation. So we've got A gas plus B goes into C plus D. The equilibrium expression for this, so we've got Kc is equal to the concentration of the products, so C times D, so the product of the concentration of the products divided by the concentration of the reactants. And that's it. That's the equilibrium constant. So if we had this if we knew at a particular temperature this reaction was at equilibrium, and we knew the concentration of all of these reactants and products, we could put that into this expression, and that would give us Kc. So a value of Kc greater than 1 would indicate that there's more products than reactants, or less than 1 would indicate that there's more reactants than products. And that is shown by this reaction, by this equation, because if this is a really large number, larger than this, then the value is going to be much smaller than 1, and vice versa. So that is the equilibrium expression. So some things to note about this is that if, for example, we only had one reactant going into two products somehow, we would just write it like that, we'd take out that extra reactant. And the other thing is that if we were to have like A plus 2B goes into C times D, we put this coefficient to the power of the concentration. So this would be AB squared, like that. Okay? And then the final thing, so that's, well, to write this down, so if you want them to take any notes or anything, we add the coefficient to the power of the concentration. And the other thing is that we do not include solids or liquids. So that means we only include things in the aqueous state or in the gaseous state. So if this product here, instead of being a gas, if that was a solid, then we would not include that in our equilibrium constant. That's because the concentration of a solid doesn't change. And that is the equilibrium constant. So we'll have a quick look at a past exam question now, and how that might be, how we might use that to answer the past exam question. So let's scroll down, let's get this up. Doesn't want me to be able to bring it down. Okay. Let's zoom in. Great. So we've got the equilibrium, write the equilibrium constant for the conversion of gaseous carbonyl fluoride, COF2, to the gas carbon tetrafluoride and carbon dioxide. So here we're going to have Kc is equal to the concentration of the products, and everything is in the gas form, so there's no problems there with including everything. CF4 CO2, and then that is going to be divided by COF2, and then the trick here, see if you can work it out before I do, is that we put the 2 to the power of that. And that's our equilibrium expression. So that would be an achieved mark there, just like that. The next question is calculate the Kc for this equilibrium if we're given the concentration of all of these reactants and products. So Kc will be equal to 0.80 times 0.80. So you could put 0.80 squared if you wanted, and that is divided by 0.040. But that is going to be squared because we've got the squared value there. And so that equals 400. And there's no units for the equilibrium constant. So 400, so that indicates that we've got far more products than we do reactants. And we can see that our reactants is a much smaller value, 0.04, compared to our the value of our reactants. No, products. Thank you. So that's the equilibrium expression. In the next video, we will be looking at Le Chatelier's principle. See you then.